So I would like to welcome on stage Abe Kleinfeld, CEO of GridGain, and Jeff Baehr, General Partner at Almaz Capital Partners. Let me say a few words. So Abe's career spans 4 decades. He was building companies, going through mergers and acquisitions and IPOs. He led Encircle from early stage through 10 consecutive years of revenue, growth, profitability, 2 acquisitions, over 6,500 enterprise customers worldwide, and 40 million in annual sales. Then in 2013, the company was acquired, and now Abe is the CEO of GridGain. So he's transforming, he's leading the company, which is the leader in the open source in-memory computing platform. GridGain, with Abe's management, tripled in annual sales growth and raised $16 million in Series B venture financing. Now, our moderator is our dear supporter, partner, and friend, Jeff Baehr. Jeff is a general partner at Almaz Capital, and he invests in areas ranging from security and networking to analytics and big data technologies. Previously, Jeff was a general partner at US Venture Partners, and he still remains there as advisor. Before that, he served for 12 years as Chief Network Officer for Sun Microsystems. So, welcome.
Thank you, Anna. Thank you. So I think I'll start off. Almaz is a venture capital fund that we are closing our 3rd fund of $250 million very shortly. And what we look for is something that changes the equation fundamentally. It's very hard to find technology which is broadly applicable, but also doesn't require people to re-architect either their data centers, their networks, or their systems. And what we're really looking for in a lot of areas is scaling. You know, people talk about scaling, but people don't understand the scope of what we're talking about with scaling. So I'll give you an example. One of our companies is running a job at Google. Every night, it's 2 million CPU hours every night. And when we asked the Google guys whether we could use their infrastructure, they said, sure. And the reason I said, what 2 million CPU hours? They said, our instrumentation doesn't start until 3. So that's the scale of what we're talking about, internet scale. So when we found GridGain, we found a company that fundamentally changed the equation by using real computer science in making databases and transactional systems run a lot faster. So I'll ask Abe to kind of describe what GridGain's about, and then we'll take it from there.
All right, thank you. So my name is Abe Kleinfeld, President and CEO of GridGain. And GridGain is a commercial company behind probably the most popular open source in-memory computing platform in the world. It's called Apache Ignite. And essentially what Apache Ignite is a layer of software that slides in between your applications and your data sources, your databases. Your applications can be written in anything. Your databases can be anything. They can be Hadoop, SQL databases, NoSQL, just file systems. So it slides in between your applications and your databases, and it delivers speed and scale. Speed comes from in-memory computing, where you move your data from the disk drive into the RAM of the computer, and therefore you can access that data between 5,000 and 1,000,000 times faster than you can on disk. And the scale comes from distributing the compute, not just the workload of, not just the data, but the actual computing across a virtually unlimited number of commodity servers. And so essentially what it is massively parallel computing. So the combination of in-memory speed and distributed computing turns out to be exactly what almost everything today requires, especially all modern applications. And so it turns out that speed and scale is what everybody wants, and we happen to be in the right place at the right time. And GridGain is the commercial company behind this open source project. We actually developed this software as proprietary software for a period of about 10 years before we put it out into the open source world. And to give you an idea of how popular it's become, Last quarter there were 18 million node starts of Apache Ignite or GridGain and around the world, which works out to at least 2 node starts per second somewhere in the world every single day of the year. And that's been growing at a rapid pace. So it's very, very popular.
Thanks. So maybe what you could do is, what strikes me is that in-memory computing has been around for a long time. And what's changed? Why now? Is it the cost of memory? Is it we have smarter computer scientists? Also, yeah. So what's making it happen now?
A number of things have happened, but it all comes down to really demand and economics, but also maturity. In-memory computing has been around for a long time. It's been around since the 1960s, maybe the 1950s. And the concept of putting data into RAM and accessing it much faster has been around for a long time. Caching was a very popular thing. But caching and in-memory computing platforms today, modern ones, are dramatically different. These new platforms are really the system of record. You're actually running your business on an in-memory computing architecture today versus just trying to speed up your database. So there's a lot of maturity that's happened, but what really created the demand was really the last 10 years. If you go back, just go back 10 years, this thing was just being introduced. And it wasn't for another year or two that the App Store, before the App Store would come out and you would start using these apps. So before that, you go back much more than 10 years, a huge application in a company might have 50,000 users. It was mostly used internally inside of organizations. And if you were a software vendor, most software vendors were shipping software that would be used internally within these organizations. So they would populate that software with all the hardware that was necessary to run and support the number of users that company needed. The concept of cloud computing and shared infrastructure to support tens of thousands or millions of customers off of a single shared infrastructure system didn't exist just 10 years ago. It was just starting to take off. AWS was just being introduced 10 years ago. Facebook was just coming out of the university 10 years ago. So if you go, and really probably in the last 5 to 7 years is where the true scale and demand for scale has really emerged. So it's easy to forget how quickly this has happened. It's really, the demand for speed and scale has just emerged dramatically, and the cost of memory has come down at a dramatic pace. It's been 30% per year drop in the cost of memory for decades, to the point that now it's effectively free. So, that combination of demand for speed and scale and the really irresistible economics makes it so that, the last 5 to 7 years is where in-memory computing finally took off.
So when we looked at the company, we said there were the founders of the company, 2 very smart Russian guys, very good computer scientists, and with a big team in St. Petersburg, really smart guys. This is really hard. This is not something like building a website. This is true computer science, because what attracted us was that for those of you who are in the database world, this is fully ACID compliant and you can run it across thousands and thousands of cores if you want. Typically people run it on a smaller number of cores to start off with. But what we found was that it changed the economics of what people were doing with their systems by orders of magnitude. And at the same time, it didn't require them to throw away everything that they'd spent the last 10 years building. So what do you think the kind of macroeconomic drivers are that are pushing this out? Why is the demand so huge?
Well, the short answer really is digital transformation. If you look at most major corporations today, they're going through a massive transformation where they're literally creating a digital twin of the organization. They are instrumenting everything. The customers, are instrumented through devices like this. It won't be long before you're wearing stuff. You're already wearing watches. And so the customers are being instrumented, the products are being instrumented, the supply chains are being instrumented, the inventory is being instrumented, everything is instrumented, and everything is producing and consuming data. And the organizations that are able to leverage that data to make decisions in real time based on what's happening in their business on the spot are the ones that are going to look like they're employing black magic and are going to win the day in the modern business. And the only way you can do that today is through in-memory computing. it turns out that traditional software architectures and even hardware architectures that are out there right now essentially separate decision-making from production systems. So they separate the operational data, where you do your transactions and you run your business, from your data warehouses. So what you do is you take a snapshot of your operational data, you go through this long process that can sometimes take days, you move it over to a data warehouse, you run your analytics and find insights into your business, and then maybe it gets put back into the operational side of the house. That can take days or weeks, and you're usually making decisions based on information that's a day, a week, or a month old. That's not what the modern world wants. That's not what digital transformation is about. What digital transformation is about is being able to get insights right out of your operational data instantly and have those insights impact the operational data. If it's raining in Kansas City right now and umbrellas are flying out the door from a retail store, you want to be able to send more umbrellas to that retail store right now, not next week, not next month. You want to be able to change the price of those umbrellas right now to leverage the business opportunity that exists. Not next week when it's sunny out or when it's snowing out. You want to do it right now. And every major corporation wants to go through that. So everybody is going through a transformation where you're going from two separate stacks, your operational data and your analytics data, to a single unified in-memory architecture that scales and allows you to produce results from that operational data in real time.
Well, so what we always look for as VCs is who's the market you're selling to, how much are they going to pay, and we typically, if a small company comes to us and says, I've got a $1 million piece of software that I want to sell to the Fortune 10, and there's 6 of us, the answer is it's not going to work because the Fortune 10 guys or Fortune 50 aren't going to buy it. On the other hand, there's the exception to the rule, which is, in looking at what people are doing with this, who do you think is the premier user of in-memory computing? It's the financial guys, because the financial guys, milliseconds make a difference. So maybe you could list a couple of the customers that we have that are using this at scale.
Yeah, I mean, if you walk up and down Wall Street right now, virtually every major bank is using Apache Ignite. But for example, a lot of you are from Eastern Europe or Russia. The largest bank in Russia and Eastern Europe is Sberbank. And Sberbank went through a long process they decided to go through this digital transformation thing early. So they're really leading the way. And they made a decision to move all of their banking applications in memory. And they made a huge decisions to invest in GridGain and to deploy GridGain across the entire bank. GridGain is becoming the system of record for the bank. All applications are in memory. They're rolling out over 1,000 servers. I think it'll be something like 1,500 servers across 11 time zones, 22 countries. And these servers are each configured with about 1 terabyte of RAM. The goal is not to touch disk at all. The moment you touch disk, everything goes to hell, because the difference in speed between RAM and disk is RAM is about 5,000 to 1,000,000 times faster than disk. So you don't want to touch disk. It's hard to grok that, but think of it this way. It's like the difference in speed between a banana slug in your garden and a fighter jet flying at twice the speed of sound. That's the difference, the relative difference in speed.
So we have customers as varied as American Express, Barclays, Sberbank. We have customers in the travel industry who needed to speed up their searches of fares. We have people all across different industries. But the salient point here is that it started out as 2 guys with a really good idea who put together a world-class team in St. Petersburg, and they built something that is the right thing at the right time. There's no underestimating luck. But maybe in the remaining 5 minutes or so, you can talk about other areas that it's applicable to. So if you can speed up things that take a long time, that transcends just databases. So we're moving into speeding up the ingest of data for machine learning by orders of magnitude. So maybe you could talk about where the future lies in the remaining 5 minutes.
Yeah, wherever you need to process data fast or do fast transactions or do fast analytics or combine all of that into one place, do fast streaming, In-memory computing, it just can't be beat. And also, wherever you need high availability, there's nothing like a distributed architecture for high availability. And so, you know, the typical use cases are the technology industry is OEMing this technology on a regular basis. Huawei, for example, is their new telco, the next generation telco systems are all built on this. If you look at Workday, for example, Workday is one of the largest SaaS companies in the world. You know, they built that system from the ground up to be in memory, but it turns out that, as Jeff said, it's really hard to build this in-memory technology. It takes about 10 years. There's no shortcuts to it. It's hard. If you talk to Gartner, they'll tell you there hasn't been a new company, a new entrant into this market in about 6 or 7 years. It's hard to do. And Workday figured out that they built in memory, but they couldn't build it to scale. And so they won a deal with Walmart early this year, and that deal was so big. Walmart has 2 million employees, so it's 2 million seats that you know, Workday won a deal for. And as soon as it got announced, their stock price went up by $7 billion. Their market cap went up by $7 billion. It went up by 25%. And they needed to do something to scale. And so they employed GridGain now. That's what they're building Workday on. So SaaS companies, banking, anybody that's doing machine learning where you have large, sparse data sets that you need to be able to process through very, very quickly. Any kind of you know, deep data processing where you have to do a lot of heavy compute like drug discovery. And then a lot of basic stuff, like if you're building, you know, a basic messaging system and it needs to be fast and support a lot of users. So, you know, just a broad range of applications. It's hard to come up with something that doesn't require speed and scale today, because everything has to operate at internet scale or at web scale, and everything has to be in real time. So it's hard to come up with examples of things that don't require in-memory computing. And, you know, in the last, you know, 2 minutes, I would point out to most of you, if you're building software companies today or new technology companies today, and you're building it on traditional disk-based computing, you know, traditional databases and disk-based computing, you're building for yesterday. You really should be building in memory. Build that into your architecture early, because it's hard. It's not that simple to transform once you've invested heavily on the other side. Build in memory, build for scale, build for speed. If you want to be able to scale your company, don't re-architect later. Build it right now in the right way. Build for tomorrow, don't build for yesterday.
Well, with that, I think we'll conclude. And where we're going is, I hope you see through the discussion that we look for something that employs some application that is hard to do. It requires real computer science and real knowledge. And we look how that can affect corporate customers. And those are the guys who have the money. And we go after the money. So consequently, we've done very well. And my friend Abe, is always a pleasure to go to board meetings, because when everything is going up and to the right, board meetings are great. When everything is going down to the left, board meetings are not so much fun. So it's always a pleasure. So I'll just say thanks, Abe. I appreciate it.
Thank you. Thank you.
Thank you.
Thank you, everyone.